So today we will be starting with a new lesson. Are you all ready? So I suppose everyone is already ready. So let us start. We begin with our initial task titled Get Me Ready to Party. Okay, so we have here a situation. You are going to study it and then answer the questions that will be posted later. We will do this in groups. Okay, so we will divide the class into 4 groups. Okay, by counting off. Okay, Jenny, will you start counting off with 1, 2, 3, 4? Okay. So our last number is 2. Okay, now you go to your own groups. Group 1 will stay here. Group 2 will stay at the back. Group 3 will stay here, and then group 4 will stay also at the back. You form a circle so that you can communicate with your group mates easily. Okay? So I will read the situation given. A close friend invited Anna to her birthday party. Anna has 3 new blouses. She has stripes, long sleeve and sleeveless, and 2 skirts, blue and black, in her closet reserved for such occasions. So each group will be given cutouts of those blouses and skirts. Okay? And then you are going to use those to answer or to present your answers later on. Okay. Then each group will have to answer the following questions. First, assuming that any skirt can be paired with any blouse, in what ways can Anna select her outfit for the party? You have to list or illustrate the possibilities. Okay, so for group 1 and group 3, you are going to illustrate the possibilities using the cutouts of the blouses and the skirts that I will be providing you, while group 2 and group 4 will be using the listing method. So you are going to list the pairs of blouses and skirts that Anna could wear to attend the party. And then for number 2, how many blouse and skirt pairs are possible? So you are going to count the possible pairs of blouse and skirts that you have determined using the illustration method and the listing method. And then for number 3, can you show another way to find the answer in item number 2? So aside from the listing method and the illustration method, what other methods could you think of to answer the question number 2? Okay, so I will be giving you 5 minutes to answer this activity. Work cooperatively and work quietly so that we can maximize our time. Okay, your time starts now. If you have questions, feel free to ask them. Okay, so time's up. Your 5 minutes is over. Okay. Could anyone from the group present their outputs in front so that the other groups could also learn from your outputs? Okay, so let us have the sharing. Okay, who would like to start? Okay, yes, group 1. Please post your answer on the board and then have someone to present your output. Okay, followed by group 2, then group 3, and then lastly, group 4. Okay, based from our previous activity, what do you think will be our topic for today? Yes, Jenny. Okay, so our topic will be on permutations. Okay, now before we proceed in discussing our topic, okay, let us have your learning targets. So this time, bring out your math notebooks and then create or set your own learning targets. So based from our topic, which is permutations, okay, you set at least 3 learning targets. So at the end of the discussion or at the end of the lesson, what are the targets that you wish to accomplish? So you state them using the format I can, and then you supply the missing part. You do this for 3 minutes. Okay, 3 minutes is over. Who would like to share his or her learning target? Yes, Jason. Okay, aside from Jason, who would like to share his or her learning targets? Yes, Mark? Okay, very good. Okay, so now let us see whether your learning targets matches our learning objectives set for this lesson. So I will read our learning objectives. First, we will define what is permutation. Then second, we will determine the formula in finding the number of permutations of objects. Third, we will distinguish the different types of permutations. And then fourth, we will determine the formula to use in each type of permutation. Fifth, we will apply the different formula in finding for the permutation of certain objects. And then lastly, we are going to solve real-life problems involving permutations. So I think this learning targets that you have set earlier matches our learning objectives or our lesson objectives. So stay focused as we go with our discussion and different activities. Okay, now first, let us study the given illustration. We have here 4 potted plants. Okay, let us suppose that these are different 4 potted plants. And then, we are going to arrange 3 of them in a row. Okay, so we have 4 potted plants, but we only wish to arrange 3 of them in a row. Okay. Now, the question is, in how many ways can this be done? Just like what you have done earlier with matching the blouse and skirt of Anna. So there are many possible ways to match the blouse and the skirt of Anna. Now this time, let us use 4 different potted plants. But this time, you are going to use only 3 of them and then arrange them in a row. Okay, the question is, in how many ways can this be done? Okay. Who would like to answer? Okay, I guess this activity takes time, so you can use the listing method, okay, in answering the question, or you can use the illustration method. You can draw, okay, whichever method suits you well. Okay, who has the answer now? Yes, Angelo? Okay, so the correct answer is 24. So there are 24 possible ways to arrange 3 of these potted plants, 4 potted plants in a row. Okay, so what method did you use, Angelo? Okay, you made use of the listing method. Who else used of another method? Okay, so Jenny made use of the illustration method. Okay, do you have the same answer with Angelo? Okay, yes. So they have the same answer. Jenny has also 24 ways of arranging the 3 potted plants in a row out of the 4 given potted plants. Okay. Now, what do you call each possible arrangement? Yes, Mark. Okay, we call that permutation. So each possible arrangement is called a permutation. Okay, now, suppose there are already 50 potted plants. So you are no longer dealing with 4 potted plants only. Suppose there are 50 potted plants. Okay, do you think you could still get the answer if you are going to use the same method that you have used earlier? Okay, the same method as listing and drawing or illustrating. Okay. Could it be possible? Okay, yes, it could be possible, but it would take much of your time. Okay, so what can we do about it? Okay, here comes the different formula that we have to use in finding for the permutation of certain objects. Okay, so using the listing method, you could get these arrangements. Okay, now, So I have mentioned a while ago that each possible arrangement is called a permutation. So what is a permutation? Could someone read what is flash on the screen? Yes, Angela? Okay, so I repeat. Permutation is the act of arranging the members or a set into a sequence or order. Or it could also be a possible arrangement. So permutation here is defined as a verb and as a noun. So for the first one, it is a verb, it is the act of arranging. And then the second one, it is the outcome, it is the possible arrangement. If there are n objects which will be arranged r at a time, it will be denoted by p of n of r. Okay? N is the number of objects, while r will be the number of objects taken at a time. So if we would go back to our example earlier, we have 4 potted plants, and then we wish to arrange 3 of them at a time in a row. Then we could use P of 4 of 3 to denote the number of permutation possible. Okay, so the question a while ago, suppose that there are already 50 potted plants and we wish to arrange 5 of them at a time. What is the number of possible arrangements? Now, how could we answer this question? Okay, so just like what I've mentioned earlier, here comes the formula in finding for the permutation of certain objects. Okay. To answer this question, we can still use the listing method or the illustration method, but as I've said earlier, this would take much of your time. Now, how do we solve the permutation of n objects taken r at a time? Okay. Now, before we go to that, let us take a look at these symbols. What do you call these symbols again? Okay, so we call these the different punctuation marks. So we use this in writing sentences or questions or statements. Now, how do you read these statements? First, okay, yes, Jason. Okay, very good. So we read this as, I love mathematics. How about the second one? Yes, Anna. Okay, very good. So we read this as, do you love mathematics? And how about the third one? Yes, Cherry. Okay, so we read this as, we love mathematics. Okay, so there is a certain emotion added into it because of the exclamation mark. Now, how about this one? How do you read this one? Okay, do we read this as 5? Okay, so no. In mathematics, the symbol exclamation mark denotes a different function. Okay, so in this one, we read this as 5 factorial. So the exclamation mark denotes the notation factorial. Okay, now what is factorial, and how do this concept is used in finding for the permutation of certain objects? Okay, now we have here the factorial of a positive integer denoted by n, or again denoted by n factorial, is the product of all positive integers less than or equal to n. The value of 0 factorial is equal to 1 according to the convention of empty product. Okay, so 0 factorial is always equal to 1. Okay, now to better understand this concept, let us have examples. Okay, so first one, we have 4 factorial. So we have stated a while ago in the definition that the factorial of a positive integer is the product of all the integers equal or less than or equal to that integer. Okay, so we have 4, 3, 2, and 1. So we have 4 times 3 times 2 times 1. So 4 factorial is equal to 24. Okay, same is true for 8 factorial and 3 factorial. You just have to find for the product of all integers equal, less than or equal to that integer. Okay, so we have 8, 7, 6, 5, 4, 3, 2, 1, and 3, 2, 1. So we just have to get the product. Now, how is factorial being used in getting the permutation of certain objects? Okay, now here comes our formula. So to solve the problem posted a while ago, that if we have 50 potted plants and we wish to take 5 of them and then arrange them in a horizontal manner, then we will use the formula in finding for the permutation of n objects taken at a time to facilitate our solution, so that we will not be consuming so much of our time listing the possible arrangement or drawing the possible arrangement. So we will just use the formula. And as you can see in the formula, we have there the factorial notation. So we will be using the factorial notation in the formula. So the formula is the P of n of r is equal to n factorial over the quantity n minus r factorial, where n is the number of objects and r is the number of objects taken at a time. And n should also be greater than or equal to r. It cannot be that the total number of objects would be greater than the number of objects that you will take at a time. Okay, now, to better understand how to apply this formula, okay, let us have an example. Okay, so for the first example a while ago, that we have 4 potted plants and we wish to take 3 of them and arrange them at a time, then we have the notation P of 4 of 3, and then to get the number of permutations, we use the formula n factorial divided by the quantity 4 minus r factorial. So our n is 4 and r is equal to 3. So we have 4 factorial is 4 times 3 times 2 times 1. And then 4 minus 3 is 1 and 1 factorial is 1. 1 factorial is the same as 0 factorial. Okay, so the answer now would be 24. Okay, now you try on your notes, on your mathematics notebooks, okay, the question posted a while ago, that if we have 50 potted plants and we wish to take 5 of them and arrange them at a time, what would be the permutation? Okay, in how many ways could it be possibly done? Okay, aside from that, let us also try the following. Number 1, find for the permutation of 5 of 2 and the permutation of 4 of 2. Okay. Now, who would like to present his or her solution on the board? Okay, for number 1, we have Mark. Number 2, we have Angela. Number 3, we have Anna. And now, write your solutions on the board and then present them to your classmates. Okay, so let us give a hand to our presenters. Thank you. So your answers are all correct. Now, let us move to the second type of permutation. Okay, we have the permutation of n objects taken n at a time. Now, what do you observe? Okay, correct. We have equal numbers or equal numbers of objects and the number of objects that we have to take at a time. Okay, so the formula in finding for this, the permutation of this one is simply n factorial. You just have to find for the factorial of the given number of objects. So for example, in how many ways can 5 people arrange themselves in a row for picture taking? So you are 5. Example, there are 5 of you and you wish to have a picture taking. In how many ways can you arrange yourselves? So we simply get 5 factorial. Okay, and 5 factorial is equal to 120. So there are 120 ways that you can arrange yourself in a row for picture taking. Okay, so you have to remember that. And then for the third one, we have the distinguishable permutations. Example, we have here the word even. Okay. And if we are to arrange the letters of the word even, how many permutations would there be? Okay, so we are to take all of the 4 letters. So you might think that we might use the formula earlier. So we just get 4 factorial. But take note, we have to find for the distinguishable permutations. And we have here a letter which has been repeated. And what letter is that? Okay, it is letter E. Okay, so to better understand this one, we will have a table here and then we have made the listing of the possible permutations of the letters of the word even. Okay, so in each box, you could notice that the arrangement are just the same. Only that we have only interchanged the first letter E and the second letter E. But it doesn't matter because they are the same, which is letter E. So for even and then even on the first box, that is considered only as 1 permutation. So instead of 4 factorial, which is 24, we would only have 12 possible ways. And then we have here the formula. So we have here a different formula to be used when determining distinguishable permutations. Okay, so we have P is equal to N factorial over Q factorial, P factorial, Q factorial, R factorial, and so on and so forth. Where N is the number of objects, P objects are alike, Q objects are also alike. So you have to determine the objects which are alike. So in our case, in here, for the word even, okay, the objects which are alike is letter E. Okay, we have another example. We have the same example here, the word even. So the number of objects are 4. So we have E, V, E, and N. For letter E, we have 2. Letter V, we have only 1. And letter N, we also have 1. Okay, so if the number of objects are not repeated, we can omit them in the formula because 1 factorial is just simply 1. So we can reduce the formula into 4 factorial divided by 2 factorial. Okay, so we have 12 distinguishable permutations. Now, in your notes, you have to try this one. How about the word 11? So in how many ways can we arrange the letters of the word 11? Okay, who would like to post his or her answer on the board? Yes, Jason. And then explain it so that your classmates could also understand the solution. Okay, let us give a hand to Jason. Very good. Now, let us proceed to the last type of permutation, which is circular permutations. Okay, this time, instead of arranging the objects in a vertical manner, or a horizontal manner, or a linear manner, we will be arranging the objects in a circular manner. Okay, so for example, we have here a table and there are 3 of you. In how many ways would you arrange yourself around the table? Okay, so for horizontal arrangements or linear arrangements, we can produce 6 possible outcomes. But for circular arrangements, these 6 possible arrangements could only be reduced to 2. Why? Because, okay, we have listed here the possible outcomes. We have 1, 2, 3, 2, 3, 1, and 3, 1, 2. Okay, those arrangements are just the same. Okay, and then for 1, 3, 2, 3, 2, 1, and 2, 1, 3, those are also the same. Okay, so if you would take a look at the arrangements here, okay, so those arrangements are just the same. Okay, these are also the same. So in finding for for the possible arrangements in a circular manner, we have to use the formula for circular permutations, and that is the quantity n minus 1 factorial. So in our example earlier, we have 3 objects to be arranged in a circular manner. So we have 3 minus 1, and that is 2. 2 factorial is equal to 2. Now let us try this problem. Okay, number 1. A teacher has 5 different tasks which she wants to assign to her 3 students in a ratio 1 task is to 1 student. In how many possible ways can she do it? Okay, so the male will answer this problem, and then for the female, answer this problem. There are 4 of you who went to eat lunch on a restaurant. In how many ways can you be seated around the table? Okay, are you done? Okay, 1 from the male will answer the problem given to them, and then 1 from the female will also answer the question given to them. Okay, let us have some volunteers. You may just go to the board and show your solution. Okay, do you have the same answer with their answers being posted on the board? Okay, very good. Okay, so let us give a hand to our volunteers. Now this time, okay, let us apply what you have learned. So we will have a paired task. You have to find your own partner. Okay, choose your own partner, and then you will work on the given activity sheets. Okay, this activity is titled Patterns of Nature. So we have here a pattern, and then inside those patterns are problems, okay, about permutation. So you have to find for the permutations. And we also have a direction here that if your answer ranges from 1 to 200 or 0 to 200, you have to color that part of the pattern with yellow. And if your answer ranges from 201 to 500, you have to color that part with blue. If your answer ranges from 501 to 1000, color that part with red. And if your answer ranges from 1001 and above, you have to color that part with green. And then for the parts which are not included on the activity, you can color them with your choice. So you can choose any color of your choice. And then we have here an additional task. We have 2 worded problems here. You have to show your solution inside the box. So work cooperatively with your partner so you can finish the task within the given time limit. So I'm giving you 10 minutes to work on this activity. Okay, your time starts now. Okay, your 10 minutes is over. Kindly pass your activity sheets. Okay, now this time, let us have a group activity. Okay, now let us follow the same groupings a while ago with our initial task. So we have here group 1, then group 2, group 3, and group 4. So I will be giving you QR codes. And then using your cell phone, which I have instructed you yesterday that you should bring your cell phone and have it installed with the QR code reader. Okay, do you have them? Okay, very good. So we only need 1 cell phone in each group. Okay, one will be reading the QR code using the QR code reader in your phones to reveal the problem. And then the rest would be answering the question posted in this QR code. Okay, so I will be giving you three sheets of QR codes per group. Okay, so you are given 15 minutes to accomplish this one. Write your solution in a piece of cartolina, and then after answering, you may post your solutions on the board, and then assign one to present your outputs. Your time starts now. Okay, your 15 minutes is over. Let us now have the presentation of your outputs. Group 1, please start. Followed by Group 2, Group 3, and Group 4. Okay, let us give a hand to our presenters. Do you have questions with their solutions? Okay, do you agree or disagree with their solution? Okay, if there is none, now let us proceed to writing your reflection. Now bring out a piece of a clean sheet of paper and answer this question. How does the concept of permutations help in forming conclusions and in making wise decisions? Relate it with your life as a student, or your life as a child at your home, or as a member of the community. Okay, so you have to reflect on how you could use the concept of permutation in your day-to-day life, especially in forming conclusions and wise decisions. Okay, I'm giving you 5 minutes to do this. Okay, your 5 minutes is over. Please pass your reflection paper. Now, do you have questions about our topic today? Is everything clear about you? Do you have any point of clarifications? Points that you have not understood well? Okay, so if there is none, okay, let us have our quiz. So I will be distributing you your quiz materials. So for the direction, you just have to encircle the letter of the best answer. Okay, so you are given here a 10-item multiple choice type of quiz. Okay, so you just encircle the letter of your answer. Okay, so this will be good for 15 minutes. So kindly get one and pass. Okay, your 15 minutes is over. Kindly pass your quiz materials. So that is all about permutations. Okay, do you have still questions about our topic? Okay, you can read other books. We have so many books on our library that you can read about this topic, or you can search the net for additional or supplemental activities or supplemental concepts, knowledge about this topic, so that you can master about permutation. So that would be all. Good day.